Hello and welcome everybody. This is Noah, and in this video we're going to do some review of fraction reduction, multiplication, and division. We're not going to go deep into this. This is just a review, so we're just going to do a few problems and look at some strategies, remind us of the rules for how to do this, and hopefully find ways of doing it more quickly as we move forward. So yeah, we're given a list of problems here where just some arithmetic problems where we're asked to reduce or multiply or divide as indicated. Let's just start nice and simple with the first one with our reduction problem. We have 90 divided by 54. And so we could look for, we want to reduce this. We're trying to find what goes into the top and bottom both that we can then divide this down. And we could try and find a big number that goes into both, but I like to just start small. I'm just going to divide the top and bottom by 2 and maybe take a few steps to do this. And I might do this problem a second time to see how we could look for a bigger number to maybe do this more quickly if we see it. But I can see that both numbers are even, and so I'm going to start with just, can I divide them both by 2? Yes, I can. I get 45 over 27. And then what I'm thinking is, okay, I can't divide these numbers by 2 again, so how about by 3? Could I divide them by 3? And in fact, we can. So let's change that to red. I can divide the top and bottom by 3 here. And if we divide 45 by 3, that's going to give us a 15. And 27 by 3 is a 9. And then I say, oh, I could do that by 3 again. 15 divides by 3, 9 divides by 3. And this will give me a 5/3. And then I think, okay, I can't divide, 5 and 3 are both prime, so I can't reduce these any further, and so I'm done. Let's do this one more time. 90 over 54. We might notice that 9 goes into both of these. 9 goes into 54 6 times, and I think it's pretty straightforward to see that 9 goes into 90. Divide the top and bottom by 9, and that'll speed this up a little bit. This will give us 10 over 6, and then we still need to divide both the top and bottom by 2, and we would then get our 5/3. So if we wanted to do this in one step, we would have to divide top and bottom by 18, and that's a little trickier. We might have to pull out the calculator for that. And what we're trying to do here is practice doing things without the calculator right now. So keep that calculator away. This is about practicing your mental arithmetic. You're doing your arithmetic by hand and finding the numbers that go into the top and bottom. And I don't know about you, but I would really struggle with noting that 18 goes into both of those, even though it does. 5 times 18 is 90, and 3 times 18 is 54. But let's not worry about that. Let's try and see if we can do it where we're just using small numbers and using multiple steps. All right, let's look at the next one where we're multiplying two fractions. I have 9 over 11 times 13 over 24. Sorry, negative 9 over 11 times 13 over 24. I'm going to start by doing this the short way. I was thinking, do I want to do the long way first or the short way first? Let's do the short way first, and then hopefully afterwards when I do it the long way, you'll appreciate more what I'm doing this way. What I can do now is I'm not going to multiply. So first, we would multiply straight across is the common phrase. All right, so I'd go 9 times 13 and 11 times 24, and I'm not going to do that right now. Instead, I'm going to look for anywhere I can reduce. Do the 9 and the 11 reduce? They do not. But then I'm going to stick with the 9 and say, does the 9 reduce with the 24? And there it does, because 3 goes into both of those. I can divide that by 3 and the 24 by 3. And so this is going to equal negative 3 over 11 times 13 over 8. And I would honestly be looking for any other reductions, like does the 13 reduce with the 11 or the 24? And the answer there is no. 13's prime, and it doesn't go into 24 or 11, so we can't reduce anything else here. Now, what we've done by reducing first is we've given ourselves smaller numbers to work with, so our multiplication has become easier. Now, the negative comes down. Negative times a positive is a negative. And now I'm going to multiply straight across. Let's, in fact, change these instructions to purple and move them down here. So 3 times 13, that's not too bad. That's just 39. And 11 times 8 is 88. And because we've already reduced, we know that we don't have to reduce now. We've already completely reduced everything, so we're already done with the reduction, and that's our final answer. If I try this problem again, where we now do it the long way, negative 9 over 11 times 13 over 24, we can multiply across first. First, 9 times 13. I don't have that memorized. I have to think about that, and I'm trying to do this without a calculator. So I'm going to go 9 times 13. This equals 9 times 10 plus 9 times 3 is 90 plus 27. That's 117. It's negative 117 over 11 times 24. That's not a fun one to do. 11 times 24, this is 10 times 24 plus 1 times 24. That's 240 plus 24 is 264. Already, I hope you're appreciating how much more difficult this is using these bigger numbers. By reducing first, we shrink the numbers down, and then when we multiply, we make them a little bit bigger. If we multiply first, we're taking these medium-sized numbers, making them much bigger, and then having to reduce still. Now, 117 and 264, it's hard to even tell what goes into both of these. I know 2 does not go into them. And we actually know that 3 does go in from the fact that that's what we use to reduce at the top. So we can use that, and I also want to show how we can know that 3 goes in here. There's this fun little technique. It's kind of a trick. It's very complicated to prove that this always works, but the digits right here, 1, 1, and 7, those add up to 9, and 9 is divisible by 3, so the whole number will also be divisible by 3. Isn't that cool? If the sum of the digits is divisible by 3, so will the whole number. That rule only works for 3s and 9s, though, so we have to be careful. Then 2 plus 6 plus 4, that's 8 plus 4 is 12, and 12 is also divisible by 3, so 3 should work here. However, it's not exactly easy to put 3 into these. 117 divided by 3, I could use long division. 3 times, well, if I put a 3 right here, I can get a 9. And it's really subtract that, we'll get 2 and 7. And then 3 times 9 is 27. So this is a 39 on top. And then 3 goes into 264. That's also not a fun one. Put an 8 here to get a 24. Subtract to get a 2 and then a 4 and then an 8 again. So the moral of all of this is reduce first and then multiply, and the problem becomes much easier to handle. Let's spread this out. There we go. So let's do this one more time here, and this time I'm only going to do it the easier way so that we can fix something. Pushed. There we go. So that we're not spending a bunch of time trying to do a problem in a way that we don't need to. The first thing I'm going to notice is that the negatives will cancel. So we'll end up with a positive answer. But 2 goes into the 10 and the 4, giving us a 5 and a 2. The 9 is not going to go into the 5 or the 19, so that's not going to reduce anymore. The 2 is not going to go into the 5 or 19, so we're done there. So the negatives will cancel, and we'll do 5 times 19. That's going to be 5 times 10 is 50, plus 5 times 9, that's 50 plus 45, that is going to give us 95 on top. And then 9 times 2 is 18 on the bottom. And we're done because we've already reduced. So that's it. That's all we have to do for that guy. All right, now we get to our division problems. Division is the opposite of multiplication. So if it's the opposite of multiplication, what we can do is we switch it to multiplication, but we flip the second one. So we say that we're going to flip and multiply. So as long as we do that step first, then we can just follow our multiplication rules. Now nothing reduces. The 3 doesn't go into the 8s at all on the bottom, and the other one's also a 3, so there's no reduction here. This is just going to be 9 over 64. 8 times 8 is 64. That's it there, and then we'll get a problem where it looks like we might have something more interesting happening. We have 4 divided by 25 divided by negative 3/10. So I'm going to start with that same first thing. We keep the first one the same, we change it to multiplication, and then we flip the second fraction, negative 10 over 3 now. And I will notice that the 10 and the 25 can both be divided by 5 to give us a 2 and a 5 there. And looking around, 4 and 5 won't reduce, 4 and 3 don't reduce, 2 and 5 or 2 and 3 don't reduce. It always has to be top and bottom. Whenever we reduce, it's always top and bottom, never across. And that looks like all the reduction we can do. We have a positive times a negative, so this will be negative 8 over 15. And that's it. That was a good fraction. Quite a bit here in this section, so make sure you've got these understood and are comfortable with them so that we can use them in more complicated scenarios. Go ahead and work on the Now You Try problems, and we will go through those solutions in the next video. Thanks much, and see you soon.